Hello, educators, teachers. Hello, Ibu dan Bapak. Good afternoon. May I see that you're waving your hands maybe as a sign to say hello to each other. Thank you, Pak Hendro, for the opening remarks as well. So thank you, Ibu dan Bapak, for your presence and for your enthusiasm, as Pak Hendro said in the beginning, to continue to learn and grow in your competencies as teachers. So this afternoon, I am very pleased and very excited to share with you something about mathematics, of course. Okay, so allow me to begin by sharing my screen with all of you. Before I start, let me just remind you that in Mentari, every time we are conducting a teacher training or professional development program, we always love to involve all of you in the process. So please don't be surprised if every now and then, as a matter of fact, even in the next 5 minutes or so, you will already be involved in the process of learning something, because we do believe, right, when we listen to someone speaking, we're getting something out of it, but when we are able to get involved directly, we're getting even more. So that's the goal of involving all of you. And of course, it's more interactive and fun when you can get involved in the fun of doing mathematics, isn't it? Okay, so our theme this afternoon is about exposing students to non-routine problems in order to promote HOTS. I'm sure you know what that stands for. Okay, so the objectives is to be familiar with the characteristics of HOTS related tasks. HOTS, of course, stands for higher order thinking skills, and also to engage in solving non-routine problems with the goal of developing higher order thinking skills. So it is my goal by the end of the session, these are the two main takeaways for you after this afternoon session. These are the main references that I'm using in this presentation. And let's begin by doing a little bit of warm-up activity here, just to get us ready for what's coming ahead. Okay, so this activity is quite simple, and if you have your post-it notes, you might want to take those post-it notes out just so that you can get involved directly in this activity. So let me share the instruction first with you, and then I will demonstrate a little bit what I mean by this. So here, we would like to arrange numbers between 1 to 5. So there are 5 integers, 1, 2, 3, 4, and 5, in order to get the same total amount across and down. Each one of you may use sticky notes, or if you would prefer the digital version of this activity, you may access a virtual board that I have set up for you, and you may conduct the same kind of activity digitally. I understand that in the context of online learning, each one of us might be wondering sometimes, right? How can we exchange an activity that we would normally do on an offline session to an online one? So I believe Ocha has shared a link to a Jamboard with all of you. Is that what you were sharing, Ocha?
Yeah, that's
Yeah,
right.
thank you very much. Thank you very much. So let me share the Jamboard. I think a couple of you I see that have been able to access the Jamboard. So here's what it looks like. So this is actually the first example that I share with all of you, numbers between 1 to 5, and I have arranged it in such a way so that the total number across, in this case, 3, 1, and 4, and the total numbers going down, which is 5, 1, and 2, will be equal. In this case, you will obtain a number or a total of 8 across and down, okay? So do not worry if you wish to rearrange this, which I'm hoping that you would be able to do. What you need to do is you can do one of these things. First of all, you can just click on each of this digital sticky notes, right? And then you can click on the 3 dots. And when it says duplicate, you may duplicate the same kind of thing. If you wish to also use a different board, I have provided just a copy of the same board with the same instruction a couple of times so you can feel more convenient to use any of these. However, if you wish to just do this, you would prefer something more hands-on, of course, you can also do that. Can I ask the operator to help spotlight the video for everyone from my workspace so we can see how it looks like? I think it's under my name, Linda Setiawan, as well. You can spotlight that, it will be great. Okay, so here I have 5 pictures. 5 numbers really. So if I wish to do the same kind of activity, I will just rearrange these papers with numbers on them, and then I will obtain the same result as what you saw in the Jamboard earlier.
I'm sorry, Miss Linda, we cannot see the number two. Yeah,
Okay, maybe I should just rearrange. Can you see it now?
yeah, already. Thank
That's
you.
okay. Okay, very good. So you can do one of those two things. Maybe I will let you do this for about 1 or 2 minutes, and let's see how we work this out together. Let's see what you obtain from this activity. Okay. Let me go back to the Jamboard because there I think I start seeing some interesting pattern emerging from what you are working on. So by the way, while we are waiting for the results of this activity, I would like to just encourage you to try out something like this. If you have already used Jamboard for other subjects perhaps or other activities, this is also an idea or an inspiration of how you can use a Jamboard in a math class. You may use this tool for collaborative kind of activity. You may also use it for kind of like opening activity like today, like what I am demonstrating at the moment to all of you. You may also use this for an exit ticket kind of activity, however you would like to use it. You are teachers, so you know your class best, okay? But this is just an example. So let's see if anybody else come up with a different way to arrange these papers such that the total will be the same across and the same down. Okay. Okay, I can see that some people are starting to move the papers. Thank you for trying that out with us. All right, this one is an arrangement. I can see that this has been, the papers have been arranged, but I don't think the total is the same. So you might want to revise that one. Okay, of course, the interesting part of doing a digital board like this collaboratively is you get a real-time feedback, right? You get a real time, you get a real sense. Of course, we're a large class and your class are probably much smaller than what we have today. But in your classes, you can get a good sense, I believe, of what's going on, right? What's going on? Are your students working together? Are they understanding the instruction well? Things like that. Let me give maybe about a minute or so, and then we'll see if we get something. By the way, the reason why sticky notes are recommended also is because when you're using sticky notes or when your students are using sticky notes, they're easily movable, isn't it? So you can move them around easily and you can try out different combinations just quite easily as well. And that's what we want to do. Oh, I think we've got another possibility here. If you just look at the board number 3 over here, this is another combination. I see that number 3 is right in the middle, and the total, I think the total across is 8. Let me see, hang on a second. No, the total is not the same yet, so you might want to also go back and revise that one. Okay, while we are continuing to do that, let me just ask if, and Ocha, certainly you can help me noticing what the participants, whether any participants are raising their hand. Is there anybody that found another combination? My combination, I think it's still up on the board. It's 1 in the middle, and you see 4 and 3, and also 5 and 2. Is there anybody who is willing to share a different combination? I can open it up for maybe 2 for now, and we'll see if we still have a little bit of time afterwards. Does anybody raise their hand yet, Ocha?
Yeah, not yet, Miss Linda. Okay, educators, if you already have another solutions, you can use the raise hand feature.
Yeah.
And you can share your thoughts about this.
Yeah, and I can see that some people are still working on the digital board as well. I think Ibu Riana, do you have some answers, Ibu? Okay, maybe we can put you on the spot.
Okay, yes.
Okay, thank you, Iboriana. So Iboriana put number 3 and then 5 and 1. So the total of that is 9. And then across is also 9. Excellent work. Thank you, Iboriana. Is there anybody else who also has an answer that you're willing to share with your class? Remember, the restriction would be the total across and down shall be the same.
Okay, we have here someone raising hand. Hello, Mr. Raymond Dale.
Okay, sure.
Let's see. Could you please place it a little up a bit?
Okay,
Upper?
thank you.
Okay. Can you see it, Miss Linda?
Not yet. I think we will. Oh, yes, yes, yes. Now I see your
Actually, number
hand.
5 is in the middle.
Ah, yeah, yeah. Nice, nice, very nice. So number 5 is in the middle. So you've got a total of 10, I understand.
Yeah.
Okay. Thank you very much,
You're
Mr.
welcome.
for your willingness to show it. Okay, thank you very much. And Pahendro also jumped in and tried 234 and 531. Yes, let me try to arrange based on what Pahendro is showing me. So I'm gonna put 3 in the middle. I guess I can probably put this is similar to what Rihanna or Iburiana got before as well. So thank you for doing that. All right. So I guess you can, in your classes, you can decide to do this activity for a little bit, but for the sake of time, so we can continue moving on to what's ahead of us in this meeting. Let me just end that activity for now. And let's get into talking a little bit, right? So you've seen a couple of examples. I don't know if that was a little fast for you, but I think you sort of probably find something, right? And there are these two are questions that just meant to guide our discussion a little bit. But if you have a different takeaway based on what you have tried out, feel free to also share your thoughts with us. You may utilize the chat box, or you may also use the raise hand and speak up directly on your microphone. So here, there are two questions. What do you find interesting about the problem? Did you notice any patterns? And which math skills are needed or developed through the activity? So would anyone like to share their insights or their takeaways from the warm-up activity we just did? You may just type in the chat box. I think Ocha can help me read that. Or you may also speak directly if you wish to do so. I think there's one chat coming in, isn't it?
Oh, the solution from Miss Prita Yuniarti. Another solution.
Oh, that's another solution.
Yeah.
Okay. Okay. What math skills are your students using, right? Like if you're thinking of your class in this sort of activity, what math skills are being used or utilized as they are doing this activity with you? What do they need to know? That's the bottom line of my question. What do they need to know in order to solve this problem successfully, right?
Okay, we have some answers here on the chat box, Miss Linda.
Sure, feel free to read those.
From Miss Unita. Number bonding about calculation, maybe? From Miss Unita.
Wow, wonderful. A number bond calculation, right? Like when you're thinking, especially for 2, 3, and 5, 2 and 3 make 5, 5 and 5 make 10. Excellent. Thank you. Another one, please, Ocha, sure.
And also from Miss Berlianta, creativity to find different ways to get the same result.
Oh, I love that. Can you read the name of the teacher again who said that? I would like to acknowledge her a bit. Oh, thank you, Miss Berlianta. You know why I want to mention your name again? Because the creativity is actually a key, one of the key areas that we're going to discuss today. Creativity in thinking. How do your students explore the different possibilities? How do they come up with the different ways that they can arrange these papers in order to get the total numbers that are the same across and down? So thank you very much for saying that. So thank you, Ocha, for your help. So let me move forward in our presentation today. So the higher order thinking skills, let me just start with a couple of different thoughts here, and then we're going to also look at more examples later on. So at higher order thinking, students will tend to use logic than to simply remember and memorize formulas. So students will master the concepts and can solve more complex mathematics problems. Sometimes it's not very easy to determine higher order thinking. And as a matter of fact, in one of the articles that I'm reading in preparation for the session, it says there that sometimes when we encounter higher order thinking kind of problem, we recognize what they are. So sometimes it's a little bit trickier to define what they are, but when we come across those kind of problems, we know, right? But then of course, there should be some guidelines such that we know for ourselves as we are planning our lessons and as we are planning to give this kind of activity to our students, what should be the characteristics of higher order thinking skills, cases or problems. So the thinking skills, here's my point that I said earlier. The thinking skills categorized as HOTS are critical thinking and creative thinking. So indeed, higher order thinking skills ask students to analyze, to categorize, to manipulate, and create new ways creatively to solve a problem, not merely memorize facts or concepts and then apply them. So these are some characteristics of tasks that promote HOTS. So the first one, the steps to solve them are not directly predictable and cannot be determined completely at the beginning. The second one, it's not a routine. The third one, there are many solutions. And by many solutions, sometimes what it means is perhaps the numerical solution at the end might be the same, but there are many ways to get to the solution. There are many ways to think through the solutions. And lastly, it requires hard effort. Hopefully you don't feel discouraged when reading hard effort, right? What it really means, it requires a little more effort than the routine problems. So I suppose as we are looking at the different characteristics and as I am launching different activities and giving you different ideas related to those activities, I hope that I will always try to stop every activity so we can go back and reflect on these characteristics. Because in the end, of course, you teachers are going to be the one deciding on the different are the 4 characteristics, okay? And in the first activity, of course, I think as you were engaging in that activity, you see that some of these are represented, right? Like it needs creativity. It's not a routine kind of problem. Perhaps a routine kind of problem is you give your students 3 numbers or 3 integers and ask them to add them, okay? And there are certainly many solutions and it requires a little bit more effort on our part, right? As we were trying to solve it. So the first activity, which I'm very excited to share with you in a bit, but before I launch this activity, allow me to just share this clip with you because it kind of will give you a taste or an idea or a little bit of hint of what this activity is all about. So let me just share this clip. It's only 29 seconds.
One of these things is not like the others. One of these things doesn't belong. Can you tell which thing is not like the other by the time I finish this song?
All right, so the title and the song kind of give you a hint, right? Can you tell me which one that is not really the same as others, right? And in the end, you knew the answer. So let me launch before the activity, before the actual mathematical activity. Let's just take a look at this picture together. You may type quickly in the chat if you spot an odd emoji among the group here. So here's a group of emoji. There's one emoji that doesn't really belong here. Do you see it? If you do, can I please ask that you type something in the chat?
Yes, there are so many answers.
Oh, of course.
And one, they said.
Yes?
They said emoji.
Yep. So there is one emoji that's not the same, isn't it? So if you're thinking of this one, this guy right here with a frown face, yes, you're right. So the idea of this activity of which one doesn't belong, it actually originally came from a book that somebody wrote. And the title is really which one does not belong. So the book is has a collection of basically different pictures of shapes. And every single shape could actually be the one that does not belong to a group of 4 shapes. Okay, so that's the original idea, but then it's been adopted into other categories as well. And that's what I would like to invite you to also do this kind of activity. Before I show this one to you, the other thing about this activity also is it's easily adaptable to different criteria and categories. So you can do this sort of activity for your units related to numbers, your units that are related to shapes or geometry. Even for secondary classrooms, this is still easily adaptable. So that's why I would love to share this with all of you. So let's begin. So triple O, right? Odd one out, or which one doesn't belong, sorry. So the idea here is I provide you with a group of 4 items. In this case, all 4 of them are numbers, as you can see on the screen. Number 9, number 25, number 36, and number 35, okay? So what you will need to think about is which of these numbers, you can pick one, that does not belong to the group. So it means if you choose that particular number, it means the other 3 is part of the group and this one is not part of the group. Okay, so that's the question, which number does not belong to the group and why? Okay, so you may start thinking about it. And in order to get some feedback from you, this time I would like to use poll everywhere. If you've attended my session at some point, I think I saw some names on our participant list earlier. You're probably quite familiar with the way this poll works. If you have not yet done this before, do not worry, it's quite simple. I will ask Ocha again as our moderator to help me to share the link with the participant. Can you please do that?
Yeah, already, dear educators, you can see the link on the chat box. You can right away click it to access the poll app.
And then the numbers are still up here as the options for you. You may think through which number does not belong to the group. And there are 4 options certainly for you. Ideally, any number could be chosen depending on how you think about it. So I do not expect 100% answer to go on one particular option, because this is not multiple choice questions that will yield only a unique solution, but anyone can choose any number. Okay. I think it should be activated. So far I've got 100%. Okay. This is the kind of reaction that I am anticipating. So 10%, 50%, 40%. All right, let me wait for about 45 seconds more or so. So you got a chance, and we'll just take the data for what they are at the end of the 45 seconds. As I've said, this is not a typical multiple choice question where you would anticipate one correct answer. So this is exciting because I got to see, okay, the percentage keeps changing.
It's interesting that there is no one choose the B, 25.
Yeah. Maybe, okay, poll is full. Okay, that's it. That's the end of the poll then. So far, I think the final answer then would be 36% of the participants who managed to get in chooses 9. And 36%, so the same percentage, choose 36. And another 28% choose 35. Okay, so I guess I would like to hear from 3 participants. Ideally, I would like to hear someone who chooses 9, someone who chooses 36, and someone who chooses 35, please.
Okay, maybe we can invite Mr. Aziz Ibrahim because he chooses number 9. Hello, Mr. Aziz.
Okay, sure. Mr.
Yes.
Aziz?
Yes, I am.
Yes. Hello, good afternoon, sir.
Yeah, I'm fine.
Okay, could you tell us why you choose 9, please?
Okay, my answer is 9 because 9 is a unique number, yeah, but doesn't 9 is not belong to in the group. Yes, simple.
Okay, that is the one that does not belong to the group. It has something unique that makes it different from the other 3 numbers, isn't it? Okay, thank you for your answer for that. Can I hear from someone who answers 36, please?
Okay, 36. I'm going to invite Miss Rika Febrianti Rika. Hello, Miss Rika.
Sure, Miss Rika.
Hello, Miss Rika. Please unmute yourself. Okay.
Hello, everyone.
Hi,
Yeah.
Miss Rika.
Hi, Miss Linda.
Hello. So you choose 36, right?
Yes,
Uh-huh. Why did you choose 36? Why does 36 not belong to the group? Could you tell us, please?
because from all the numbers,
Mm-hmm.
36 is an even number.
Oh, so you're saying that 9, 25, and 35 are odd numbers, isn't it?
Yes.
Okay, thank you, Miss Rika, for defending your answer or justifying your answer. I think earlier,
You're
thank you so much.
welcome.
Earlier, I saw Miss Marie Chris. Do I pronounce your name correctly? Is that Marie or Mary? I think she raised her hand. Maybe we can give her a chance to speak up.
Yeah. Hello, Miss Mary.
Hi. For me, I
Hello.
wasn't able to join the poll, but I choose 35
Sure.
because 9 is a product of 3 times 3.
Ah,
25 is 5 times 5. 36
mhm.
is 6 times 6. So I chose
Wonderful.
35.
Wonderful. Thank you, Ms. Marie, for your answer. So we've heard three responses that represent represent the reason behind those three choices, right? We haven't yet found 25 yet, and maybe 25. Well, maybe 25 is somewhat trickier, but I guess I'll leave it to you for later food for thought for you. So let's just do another one, another kind of activity. So if you were still trying to get in the hang of the first example, this one is a non-number example, meaning this is geometry. Sometimes I'm thinking, why do I choose this example after the first one? Because sometimes in your class, right, at least in my experience, what I see is some students are really strong in their visual skills. And maybe when they're not shining as brightly in those units that are related so much with number, they will shine in this kind of units, right? About geometry. So sometimes it's also good to keep your examples varied so that those of your students who are more inclined into geometry type of learning can be accommodated as well. So for this one, again, kindly please help me, Ocha, to share the link for the Slido. So for this one, we're going to do pretty much the same thing. I think you know the drill, right? Choose one of these four 3D shapes. The first one is square base pyramid, and then we have cube, we have tetrahedron. So basically it's a pyramid with the base of a triangle as well. And we also have a triangular prism. So from this, you may choose one shape certainly that does not belong to the group. And in order to get some feedback from you, I would like you to just click on the link about, oh, some of you are already answering here as well. If you would be so kind to click on that app Slido so that we can see the percentage again in real time, that will be so much fun for us to watch your response. So let me just activate it. I think I start seeing it now. It's just you can't see it yet because I haven't shared it with you. Oh, some of you even answer that. Now it's activated, so you can just click on that and we'll see again how the percentages changes. I think I see some of you are also using the Q&A feature. Oh, thank you very much. A lot of you are so used to technology by now probably, isn't it? Cube, tetrahedron, and I can see your name too. You know what, with Slido, another interesting feature here is you can also click on this button right here, which is like a thumbs up. So if you agree with somebody, so let's say Diane here is saying tetrahedron. If you agree with her, you want to support her in that answer, you can click on the thumbs. And that means, yes, I agree with you or I support you in that. Okay, so I can see that 24 of you have this is what I really like about this kind of activity. Again, oh, most people, 63% of those who have accessed the poll says, oh, 68 now, 68% says it's cube that doesn't belong to the whole group. 28%, 27, oh, poor tetrahedron, it just keeps on decreasing. If this were in a classroom, you know what I would like to encourage my students as well is that this is the time. This is what I normally would say to my student. This is the time when you really have to stand for what you think is right. Right? It's like when you're voting for something. It's not really you're getting swayed by the majority necessarily, but if you really think, you know why that option is the correct option to choose, you're going to stand for it and defend it. It's not about following the majority. Okay, let's see it. Okay, now I managed to sway you again because now it's 26%. And there's also an answer for square base pyramid, 3%. And nobody answered triangular prism so far. Okay, so it's quite interesting. So while waiting, I think I could ask for the same response again. If you wish to let us know your reason, I guess cube is kind of obvious, so I'm gonna leave it last. So can I hear from those of you, even though this is a minority, right, in this poll, but surely you have a reason why you choose square base pyramid over the other two shapes. So the three shapes here are square base pyramid, tetrahedron, and cube. So let me go back to my PowerPoint presentation so everybody can look at the shapes clearly. Okay, so I guess I've got responses for square base pyramid, for cube, and tetrahedron, isn't it? All right. Can I hear from those of you who chooses the tetrahedron?
Okay, let's see. Maybe we can invite Miss Riana Sari. Hello,
Sure.
Miss Riana Sari.
Hello.
Would you please unmute yourself?
I'm sorry, I'm in the middle of meeting.
Oh, okay.
No worries.
I think Miss Marie, I see that Miss Marie is raising her hand again. Go ahead, Miss Marie, and share with us.
Hello, Miss Mary. Hello, Miss Mary.
I chose the tetrahedron because its base is not the same. The base of the tetrahedron is not the same with four-sided base.
Ah, okay. So when you're looking at the picture, the other ones have a base that is a quadrilateral and tetrahedron is not. Very nice. Thank you. All right. What about cube? I guess this is kind of obvious, right? Why you choose cube, and this is the majority. So it should not be a big problem for the majority, right? For someone to tell us the reason why. Why did you pick cube as the one that doesn't belong to the group?
Maybe we can invite Mr. Diaz, Gretchen Diaz. Hello? Hello, Mr. Gretchen Diaz. Okay, we couldn't hear from him. Maybe we can invite another participant. Hello, Miss Atika. Yeah, hello, Miss Atika.
Yes, I think for the cubes is totally different from the others who has like a triangle on it, and also with the their shape also quite different, and also the what do you call it the sudutnya juga berbeda, besaran sudutnya berbeda.
Ah,
So
okay.
that's it. The shape of triangles and the degree in it. So I think that's what I choose the cubes.
Thank you very much. So cube is the only one without any sides that is a triangle, isn't it? That could be one of the reason why you choose that one to be the one that does not belong to the group. So excellent work. I hope it's not so much about, of course, I'm glad that you were able, I think you did an excellent job just getting into the system very quickly and pick up one answer and also defending your answer. But even more importantly, again, let's think about how this activity, so I encourage you to think of how can this activity really promote those higher order thinking skills, right? Okay, this one we're not going to do, but this is just another example. So the first one was a whole number. The second one was geometry, and this is coming back again to the number. Okay, so if you like this sort of activity, do not worry if you didn't get the chance to make note of the previous two, because you will have an access to the material later. But then again, I guess you will see that in order to solve each question, or in order to answer each question successfully, you have to have a reason, right? So the HOTS characteristics certainly are, the steps are not always directly predictable. There's many solutions. As a matter of fact, for every solution that you choose, there should be a reason, right? So there could be, it's not just one single answer for all. And if you think that it requires a little bit more effort, certainly it does, because you have to combine the knowledge, some of the knowledge you know, and then apply that, right? Like, why are these three things should belong to the same group and this one does not? Okay, so it helps a student to also categorize based on what they know about those numbers or about those shapes. So definitely, it's recommended. You can try this out in your class. Okay, now this is another activity, kind of a good, I think, for a starter. I would recommend this for a starter, but of course you can also use it for different part of your lesson. And this is called a broken calculator. So shortly, Ocha will share another link so that you can also try this out in your computer. However, let me now switch to my other display, so you'll be able to see immediately what the activity looks like. Okay, so the instruction is, it's kind of like self-directed because it already has the instruction here. Basically, this is a calculator, right? A digital one. And you see that some of the buttons are colored gray and some of the buttons are colored green. So the green buttons are the ones that work. Meanwhile, the gray buttons are the buttons that are broken. So it says here, use the keys on the broken calculator to make the totals from 1 to 10. 5 has already been done as an example. So some examples for you here is for 5. By the way, I don't think I mentioned them very explicitly, so let me restate which button actually works, okay? It should be number 3, number 4. There is a subtraction here, or minus, right? And then multiplication button, equal. And here, over here, it's just to erase, right? So you get a chance to erase if you didn't get it right the first time. So the goal is now, let's try to see if we can figure out how to find ways to obtain these numbers. So 1, 2, 3, 4, and then 6, 7, 8, 9, 10. I think I see something in the chat. Okay, so 4 minus 3, thank you, Ibu Tri. 4 minus 3 times 4, let's see, 4 minus 3 times 4. Oh, it becomes -8. You know what? Because the calculator is smart enough to figure out order of operations. So I see what you were saying, but we do not have parentheses here. So the calculator will calculate it as 4 minus 12, right? Thank you, though, for sharing your thoughts with us. Is there anyone who has found a way to find any of these numbers? I will allow us just a few minutes to think through this together.
3 times 4.
Okay, sir, go ahead.
3 times 4 minus 4 minus 4 is become 4.
Let's see. That's correct, indeed. Thank you very much. So you find a product of 3 and 4. You take away by 4 twice. So you shall obtain 4. Of course, the other point of encouragement, I suppose, that you can also share with your students is when you are doing this kind of activity and someone has found, so for instance, somebody has just found the answer to 4, there could be another way to find 4. Okay, so it should not stop you from trying out a different way to get a 4. Oh, I see that there's a couple of answers here. Let me take it one by one. So somebody found number 5, and that's 3 times 3 minus 4. So the product of 3 squared minus 4 yield the result of 5. Thank you, very nice. I also see a 2 from Pak Ricky Afrianto, 3 times 3 minus 4 minus 3. So 3 times 3 minus 4 minus 3. There you go. I got number 2. Thank you, sir, for sharing that with us. And I do see an answer from Nur Miftahul Jannah. 2 times 5 minus 3 minus 5. That will also give a 2. That is correct. I just don't put it again on the board. Let's see. I'm just going to select a couple more and then we'll talk about this, okay? Okay, let's see. This is interesting. I've never tried this before. From Ibu Indah, 43 minus 33. Yes, indeed.
Wow, great.
Yeah, wow, this is what I will call, for me personally, this is a breakthrough, Ibu, because so far what I've been thinking is a single digit. I didn't think of making it 2 digits. Yeah, but Ocha, remember?
Yeah.
When we were kind of like having fun trying this activity before this session. Wow, what a breakthrough. I'm so happy.
Yeah, so creative.
Yes, you were all very creative teachers indeed. So let me just take one last one so that we can move on to the discussion part. So 4 minus 3.
3 minus 34.
Yes, it could also be 2 digits, so 43 minus 34. Yes, thank you very much. So let me stop there because you're able to see each other's answers anyway. I think somebody found something for 1, for 8, for 6. Any takeaways, teachers? Let me open up the opportunity for you to speak up about this. Maybe 1 or 2 people just quickly share with us. How do you feel about that activity? What did you take away? Just a reminder, we were talking already about the characteristic of HOTS task, right? Being not fully predictable, being not a routine, many solutions, requires hard effort. Perhaps you can also, you would like to also comment on that as you were completing this activity. Can I hear maybe from 1 or 2?
You can use the raise hand feature, educators.
Or you may also use the chat if you would prefer that way. What was your takeaway? Because remember, as a teacher, I think this is an important part whenever I'm so glad that we're all engaged in the activity, but something that you are reflecting on while or after you're doing the activity will be beneficial for you. Okay. All right, I'm gonna wait for 20 seconds more. If you would prefer to wait a little bit later to reflect, that's fine. And I will just move to another one. But I'm sure from some of the answers, you start to see also the pattern, right? There's really many creative solutions that people can think of in using those 2 operations, in particular, multiplication and subtraction, along with 2 numbers that are provided in order to come up with those results. There are many versions, educators, of the same kind of activity I used to do. If any one of you have attended any of my sessions in the past, you're probably familiar with the activity I called the Fantastic Four, which basically you're giving your students 4 of 4s, so a number 4 for 4 times, and then ask them to freely use any operation in order to come up with the results from 1 to 10. So that's also another version of the same kind of idea of this sort of activity. And certainly it promotes creative thinking because you have to make use of what you have, right? Many of you are Indonesian here, so you're probably quite familiar with the saying that tak ada rotan akar pun jadi, right? So sometimes when you are having limitations here in the sense that you do not have all of the numbers, how can you make use of those in order to obtain the results, the desirable result? So just very quickly, I'm sure you know what these are. This is just the Bloom's taxonomy of cognitive development. And when we are talking about higher order thinking skills, they're associated with the following Bloom's taxonomy cognitive level. There are analyze, evaluate, and create. So of course, we want to climb up in the pyramid of this thinking process whenever we talk about higher order thinking skills. It should go beyond remembering and understanding and even applying, right, in Bloom's cognitive level. So I hope that through the activities that we have done and more activities, you'll be able to see that indeed we are promoting analytical skills, evaluation skills, and even creativity.
Yeah, Miss Linda, before we continue, there are actually some responses from the participants here in the chat
Sure.
box.
Sure. Can you read one or two maybe?
Yeah, Miss Dirty said, need hard effort, but still fun. And also from Miss Urwatu, creativity to find the result, use many ways. And also from Miss Indah, this is great and enhance our critical and creative thinking.
Wow, nice. So critical, thank you, Ocha, for letting me know about those responses. So certainly, I do agree with you, and I'm so happy when you have those kind of takeaways, because when you're convinced, when what I'm sharing with you make you feel convinced, then you're more likely to also try these activities, right, later on. And the effects is just amazing for your students' thinking development in math class. Okay. So I think the next thing will be a Padlet. Okay. So now, educators, we're going to more of like a formal type of problems, which means that the first two is kind of like easily adaptable, but this one is more topical, okay? Which might be also good for you if you're thinking, oh, I'm a teacher teaching this particular grade level, teaching this particular topic. How can I make use of some ideas, to promote higher order thinking skills? So again, kindly, Ocha will share a Padlet link to all of you as a tool for you where you can record your answers there. If you would prefer to write on your notebook first, of course, that's fine. But let me just share the Padlet page with all of you so you know what to expect. So this is called Put On Your Thinking Caps, and I'm basing this presentation off of the my paws are here. So if some of you are using my paws are here, and you might recognize, by the way, you just need to click on the question if you want to make it grow larger. So put on your thinking cap. Typically in my paws are here, you will be able to see the section. I don't know if you have utilized them or you have not utilized them yet, but I do want to encourage you to take a look at this sometime and try it out. Or try giving it out to your students, because they are really, really good for the higher order thinking skill development. So here, the way I have set up this activity is I just took samples from primary 2, primary 3, and primary 5 problems. So those of you who teach probably more lower primary, I guess you would like to see primary 2 problems, just so that it's more directly relevant to your learner's experience. And then if you're teaching grade 3 or 4, you might want to try this out. And if you're teaching the upper primary level, which is primary 5 and 6, I would suggest that you try this one. Okay. What about if you just want to venture out of the grade level that I suggested? That's totally fine. Okay. So no worries. If you're teaching primary 5 and you want to try out primary 2 problems, that's fine. If you want to go other grade level, that's also fine. Okay. I think you can share the link now, Ocha.
Yes, already, Ms. Linda, already on the chat box.
Okay, very good. And I think there is a password there as well. So you have to insert the password in order to access the page. Oh, I start seeing the answer. Very good. Okay. Let's just use this board for the next few minutes. So you can just click, you can add comment directly, or you can also click the plus button if you wish to just post your own individual posts there. Okay, and let's just wait. So far, I've got answers for primary 3. As you can see, sometimes the way we think about higher order thinking skills is because it's higher order, right? Sometimes we wonder, is that possible to use something that is already there, like there is already a routine, and tweak it or change it a little bit to make it more challenging for the students so that they can develop their creative thinking skills? These are very good examples, educators. So as you can see, in this case, all 4 of these problems are actually subtraction problem. But there is something about some of these questions, right? Like if you think about number 1, just tweak something here. So instead of asking for the answer, you're asking for a missing number in one of these two numbers that are being subtracted. So that will give you idea, and you can easily change the digits and the numbers with other digits too, right? Okay, very good. Oh, somebody is answering for primary 2. 37 and 47. Okay, so you have picked a pair of, so the problem here is about forming two-digit odd numbers. So thank you for giving us 37 and 47. And then the next step will be subtracting those two odd numbers. And there's a little bit of conclusion part here that says my answer is an odd or even number. So it says circle the correct answer. So in other words, this question is really aiming at identifying patterns, right? What happens when you are subtracting two odd numbers, two-digit odd numbers? Do you get odd numbers or even numbers? Is the result the same all the time? Meaning, do you always get an odd number, or do you always get an even number, or you cannot be sure, right? So you see that the kind of questions I just asked you earlier, those are the kind of questions that you can also use in your class. As a matter of fact, in some of the curriculum that I know, identification of pattern belongs to one of the criteria of assessment. So you see, this is one of the skills that are deemed important. Are the students able to use the data they have to generalize the pattern, right? And not just finding the answer. I think most students will not find it too difficult to subtract 37, let's say 37 and 47. But once it get to, identify more and more, can they actually start looking for patterns? So this is a typical problem for primary 2. And pattern identification certainly helps students to leverage their thinking abilities. Sorry, I have to clear that so everyone can see the answers, okay? So educators, you may continue working on that. And if I can ask our operator to kindly highlight the video on my workspace one more time, please. And I'll just show the solution here shortly.
Yeah, it's already in Spotlight.
Okay. Okay. So here, I think I have to just find myself. Okay, I can see it now. So let me just go through this very quickly and then be ready again if you would like to share some takeaways from this. What did you find easy? What did you find difficult? And of course, when I'm asking, I'm glad that somebody says, it's still quite okay for me. And that's what I would expect, because we're all teachers, we're adults, we've been through trainings. But also think about it put yourself in your students' shoes when you are reflecting on the level of difficulty of this kind of problem. And what would they think of that? Do they think it's super difficult? Do they think it's still manageable? And that kind of thing. That's what I would like to encourage you to think through. So these are just some samples, okay? For the primary 2-1. So actually, whenever I subtract a pair of odd numbers here, as you can see, I will always get an even number, okay? And then, of course, you can expand the discussion and ask them, why do you think that is true, right? Students, why do you think that is correct? What do you remember about odd and even numbers? Do you start seeing patterns when you see, 1, 2, 3? By how many do you skip count, right? Because this is primary 2. And those kind of questions, other questions that can also promote that kind of thinking. So just think about the reason, right? Think about the connections between all the different facts you've learned so far. And for this one, I don't think this problem in particular is too difficult, right? Because it's kind of like more of a regular kind of subtraction. But for this one right here, I think for the rest, that is something a little bit tricky, isn't it? Whenever you have, let's say here, 5,000, so 5 followed by 3 zeros, and then minus what in order to get the result? Because you see how many times you have to regroup. So that's the difficulty. And also here, you have to think about the digit that is smaller than 7, but again, this digit in the hundreds place is related to the digit in the thousands place, right? So students will have to think about that, and it may not always easy for them. And for this one, it's something, 4-digit numbers minus 3,769 equals to this number right here. So you see my notes already. This says add. So you have to invert from subtraction to addition in order to find the answer. Some student might find this is quite okay actually. But it's not, it's not telling the students directly that you should add. I think if I were, an easier problem would be just give these 4-digit numbers and then ask students to add, right? But by putting it this way, setting up the problem a little differently, it actually adds up the challenge for students to do, because it's not directly obvious for them. It's not directly predictable. They should think about that first. Hang on a second, what do I need to do here? Okay, I have to add those two numbers. Okay. Let me see if anyone got to the last problem for the primary 5. Yeah, thank you. Let me show you what people got for the last one. Thank you so much for your participation. Let's see, this is the primary one. Primary one is also about generalizing a pattern. So here the question says a square and circle. So these two symbols both represent fractions that are smaller than 1. So obviously, students have to obtain some knowledge of fractions and operating with fractions prior to this question. Complete the statement by using greater than, smaller than, or equal to. Okay, so there's a little bit of algebraic thinking here as well, right? Because algebra simply means that you are changing or replacing a quantity or the unknown, sometimes we call it, with a letter. So in this case, the unknowns are represented by these two symbols, squares and circle, okay? And then it says complete the statement using greater than, smaller than, or equal to. So let's see what people get. Smaller than, okay. Okay, somebody give an example. Okay, thank you very much. It says a quarter of 1/2 is smaller than a quarter plus 1/2. And of course, when you're in your class with your students, you can also expand on this, right? You can expand on this idea. You can ask your students to work in groups and come up with examples and then justify. Are those relationships always true? Sometimes true or never true. That is, by the way, another thing or another question that you can also ask your students from time to time. Okay, can I please get another spotlight for my workspace so I can show the final solutions here?
Okay, already, Miss Linda.
Yes, thank you very much. So here I've got, this is the original questions that you've seen. As a matter of fact, one of my examples also involve a quarter. So here I just choose the square to be a third and the circle to be a quarter. So it means the first one, I will have a third of a quarter. So you see, this is actually multiple steps because you're inviting your students, opening up opportunities for them to think about what does it mean by a third of a quarter. So here I just draw a simple model. Perhaps some of you who are quite familiar with Singapore maths, you're also familiar with this kind of diagram, right? A third of a fourth is actually that, okay, that part. Because first you're dividing your rectangle here into 4 equal parts, and then you're dividing them again into 3 parts, and then you just take one small part. And meanwhile, a third and a quarter means you're actually adding, right? Adding the different parts. So in this case, it will be a third, and then you will add a quarter, right? So it's gonna be bigger. So visually, you can represent that with even better manipulatives, perhaps. But then another way to also get your students, of course, is to, some of them might just make sense of it right away. Okay, I know that this means a third of a quarter means that you're multiplying these two. So they just multiply and they got that result. Meanwhile, this two means you're adding the two of them. and you have to test out a different example. So they'll be able to find it's actually smaller than. So this will be a really good activity to do in a classroom. And I think you can do this kind of activity, as I've said, for group work, because then students will be able to communicate what they understand, the way they make sense of the problem, the way they process this problem. That will all become obvious. So I would encourage you to try that sometime. If you're using Zoom, you can always use the breakout rooms for those kind of activities, or other platforms that you're probably familiar with. Okay. So we managed to collect some thoughts, right? Some thoughts and some experiences for that. And believe it or not, so these are the 3 questions, okay? Believe it or not, this is a Q&A already. So let me just open it up for maybe 1 or 2 people. If you would like to ask any question at this point, you may share your question in the chat box, or you may also just speak up, and we'll give you the opportunity to ask your questions.
Yeah, silakan educators, if you have any question, you can type it on the chat box, or you can use the raise hand feature.
We will also have another Q&A session, by the way. So if you would like to still just looking into the whole presentation first and then ask your questions later, you may do it that way as well. Okay, let me just wait for a bit in case people are still trying to phrase your questions, or you're wondering about it and you just need some time to form your thoughts.
That's right. Maybe they are still writing the questions.
Yeah, sure. Okay, I'm gonna wait for just a little bit more. And maybe some of you, sometimes when I'm giving problems like this, that is quite interesting. Sometimes also some people we're still working on the previous questions that I gave them. I think I see that there were something on the chat.
Yeah. We have some questions, Miss Linda.
I think from Ibu Imelda, yeah? I can read it, that's fine. The question here, and I think there's also another one before that. So let me just go back to make sure that I address that. From Miss Rihanna, yeah? How to measure higher order thinking skills of the students to know that we're a success or not at promoting their skills? Okay, I think this is a good question. So this is related to the assessment as well, right? How can we truly really assess whether we are success or not in promoting the skills? Well, first of all, I just want to say that higher order thinking skills is something that we are promoting in order to kind of like developing the habits of the mind. So whenever I'm thinking about higher order thinking skills, I'm less concerned about the measurement as I am in the process itself. Because as you see, even in today's session, what we are concerned about is, okay, what are the different ways and things like that to find the solution, right? But of course, if you are a little bit more concerned about making it measurable, of course, you can come up with something such as rubric, for example, so that in an activity, so let's say if the activity we did was which one doesn't belong, of course, you can also have a simple rubric that probably says whether or not the student have identified the correct reason for their choice or not, something like that. So you can use something that you would normally do for other skills. It's just you are applying it to HOTS. But again, my answer would be we're not putting too much concern on measuring itself, measuring the skills itself, because what we want is really developing the student's mind to be able to get used to thinking creatively, get used to thinking more than one solution, thinking of alternative solution, making them used to making connection between different mathematical ideas, making our students used to putting their hard effort, right? Making them used to something that is not routine. probably the measurable ones can go more in the routine type of questions. Okay. And I'm going to get another one. And can I please ask that Ocha can make note of the questions that I have not answered now, so that later in the QA session, I can address those. Okay. So let me see. Okay, I think I would address the question from Alif Akwifianisa. How to treat our students so they can doing the problem or of HOTS question. I guess what are some of the steps, right? So that the students are feeling more confident, feeling increasingly more confident to tackle this kind of questions. And I think my answer will relate a little bit with what I answered earlier. HOTS needs, just like any other skills in mathematics, it needs time. It needs time to grow. And students also need to some time to grow in their confidence, right, in doing this kind of questions. So that's why some of the examples that I've shared in the first part of the presentation are a great way to start introducing the higher order thinking skills to the students. So they'll be able to gain confidence while getting in the routine, especially activities such as which one does not belong. You introduce it to the students once or twice, and then you're doing it a little bit more frequently. So probably not in every single lesson, yeah, because I think that will probably be challenging sometimes because you also have the routine problems, right, to give to your students. But make it a goal so that you can incorporate it more and more in your lessons, because it will help students to develop their thinking. And once they develop their thinking, they become problem solvers. So they're even more ready to solve other questions. Okay. So thank you, educators, for your questions. Now it starts coming more and more. Okay. Okay. And later I will answer more questions in the next part of the Q&A. Thank you for your enthusiasm. All right. So we're going to get into the second part of the presentation. And in the second part, you will find some examples that I'm giving you are probably geared a little bit more towards the upper primary. But then don't worry, towards the end, there will also be other examples that are easily adaptable again to other grade levels. So this is an example of the questions that I'm talking about. So you might want to even have a head start and start solving this question while I am reading it. So it says Jane and Mary has equal amount of money to spend. Each day, Jane uses $3.50 and Mary uses $2.40 more than Jane. In N days, Jane will have $16.80 left and Mary will have $4.80 left. So find N. So obviously this is a problem that make use of a letter in replacement of quantity. So it's algebra. So as I've said, it will cater more to the upper primary, such as grade 5 or grade 6. Okay. So feel free to just solve it for a bit. If you wish to share, I do not use any particular platform for this one, so you can just share in the chat, or if you wish to just speak up directly, certainly that's welcome as well. So how would you solve it? I think as much as we are concerned in the solution, in this discussion today, we're also interested to know how you actually think through your questions. So feel free, you can type something in chat. I think I've got one. Activities. It's the idea behind the activities, right, that will help us in deciding which activity worth pursuing, which activity worth distributing in our classes. Okay, do you need the question again? Okay, let me give you some time. Maybe people are still trying to think. So what do we know from this problem? We know that the two people here has equal amount of money to spend. So they have the same initial amount, okay? And each day, we also know the amount of money that each person uses each day, okay? What we do not know is the number of days that have passed since they started spending their money. But we also know one more thing. We know that Jane have certain amount left and Mary have a different amount left. So we know that Mary has less amount left in the end, okay? If you're teaching grade 5 or 6, this is probably something that you sometimes give your students. So things, sometimes when we are giving the end result and then something in the middle is missing, that can also be a way to make the questions a little bit more challenging, right? Okay, let me see if anybody is clicking. Not yet. Okay, that's fine.
Okay, we have an answer here from Miss Gretchen Diaz, 5 days.
Oh, okay, 5 days. Thank you.
And also
5 days.
from Mr.
Okay.
Moses, 5 days
Okay.
also.
Okay, thank you very much. Would any of you, maybe one of you, like to share how you figure it out with us before I show the solution? So either Moses or Gretchen Diaz, if either one of you wish to share it.
Maybe we can invite Miss Gretchen. Hello, Miss Gretchen.
Sure.
Yeah.
Okay. I just got it from the difference that I forget the name. The first and the second person, the difference is $2.40. Yeah. So the difference between Jane and Mary is $2.40. And we check the last result. The Jane will have $16.80 left, while Mary will have $4.80 left. So I subtract the difference from the last result. I got $12. So I go back to the difference, $2.40. For how many days will be $12, and it will be 5 days.
Okay, lovely. So you're making use of the difference of the remaining amount, and then you just work it backwards from there. Okay, very good. Thank you. So now the questions, now there are also more people answering. N equals 5, N equals 5 indeed. The answer is N equals 5. So let me just show you what I've got here. Strategy here, and that is by using a little bit of what some students would refer to as just use logic, right? Use reasoning. So because you know what the difference of the amount of money between the two people in the end, you know the difference is $12. And you also know that the difference between the daily spending is $2.40. Somebody is spending $2.40 more than the others. So you know, okay, the remaining amount must relate to how much they are spending each day, right? So that's how you can use it. So $2.4 times N should give you 12, and N equals to 5. Again, if some of your students have learned about algebra, they might form equations. The idea behind this algebra right here is, of course, the quantity of the money at the beginning. It's the same for the two people. So that justifies this equation right here. And then just solve it. And this one right here, a little bit visual to help. So Jane has spent certain amount and she's left with that amount. Meanwhile, Mary also has spent certain amount and she has that amount in the end. Okay, so you see that from this model, the total amount that Mary spent, it's just 5.9N, right? And that will be $12 more than the total amount of money that Jane spent. So in the end, the idea is just that difference, right? The difference in the amount that they're spending daily resulted in the difference in the total amount in the end. So that will enable the student to figure out, okay, the total number of days must be 5. Thank you for the answers that keep coming. Looks like Mr. Aziz has made use of algebra. So the second strategy here, that's what Mr. Aziz is writing as well. Thank you. Form an algebraic expression, right? And here you can even take time, because the nature of this problem is a little bit more challenging. You can even take the time and say to your students, communicate to them what's the importance of algebra and problem solving, or what's the value in learning algebra. It can help us in the process, okay? Which method is superior? Of course, the answer is not every method here. It's just a good method so long as you know how to utilize it effectively. And sometimes it has to do with your style. Can help you make sense of it. If you are someone who is an algebra person, you probably just jump into creating expression right away. Okay, so and if you're someone who would like to hang on a second, just think about the connections between the quantities, then you probably prefer this one. Okay, so that's the first one. And you know the pattern. I provided some number related questions and also some questions that are not so much number related. They're still numbers, but it's probably related with other topics such as geometry. So here I am just showing you for the next two problems where I am getting those problems from. Hub. So if you access MC-EDU Hub and you come across this part that says novel questions, those are the questions that you would like to take and examine in order to promote higher order thinking skills. So let me start with this one. And for the next two questions, the questions has to do with some drawings, some shapes, and also some overlapping areas. Okay, so for example, this one. And in a minute, Ocha, could you please share the link again to the Desmos activity?
Yeah,
so,
already, Ms. Linda.
Thank you very much. So I think let me just show it from the Desmos activity so that you know what you can anticipate. So you can click the link that have been sent. It's from Desmos Activity Builder. Okay, and let me just go to my dashboard. Every single one of you should be able to access it. And you can put your name. Okay, I see that these 4 people have been able to join in. Thank you very much. So I guess because you're teachers, I can just throw those 2 problems right away. If you're in your class and you would like your students to take a look at each problem one after another, you can also select this feature here called pacing. So your students can select one problem at a time and not having to feel stressful about another one. So let me introduce this, but if you would like to begin working on the problems right away, that's fine with me. So here's my first question. It has to do with 2 triangles with an overlapping areas. The base of the triangle A and B are shown or are given. And the base and height of triangle A, which is the bigger one here on the left with the pink color, is twice that of triangle B. So find the difference between the shaded area. That's the first one. And if you have successfully solved that, feel free to venture on the second question with similar idea, but this one is grade 6 level, I think. So this one is quite similar. You have a triangle and you have a square. One person has successfully accessed it. So thank you. It says the figure is made up of a square ABCD and a triangle EFG. The area of the square ABCD is 2/3 of the area of the triangle EFG. So you see that the two shapes, we do not know the area of the two shapes as numerical values, in the form of numerical values, but we do know that the areas of these two figures are related because we know the ratio, right? A quarter of square ABCD is shaded, as you see, that's shaded with the yellow color. The total area of the unshaded part is 72 square centimeter. So what is the length of a side of a square ABCD? Okay. So let's see. I think I have enabled you to take a look at people's answers, so you will be able to see each other's answers. If you have not used this platform before, hopefully this is also giving you an idea. If you wish for your students to solve or work through a problem or two, and you want to get some real-time feedback or a little bit of more sense of what your students are capable of doing at that point, then this platform is also a great tool where you can see your students' progress. As here, I can see some answers written down. Looks like Indah Putri is working on it and almost done. By the way, I provided two workspace here. The first one is for the sketch, and the other one you can type in words, or you can even type in some numbers there. Okay, so the idea is sometimes when you are working through math problems, you will need some kind of, in Bahasa we call it kertas coret-coret, right? We will need scratch paper. So this is kind of like your scratch paper, and the other one is going to be for the solution part. So let's see. I think a lot of you have been able to access this. It's just a matter of working through the questions here. Looks like someone is also working on this one. Let me wait maybe 1 or 2 more minutes.
Oh, we actually have someone answering here in the chat box, Miss Linda.
Sure. You may read it as well.
Yeah, from Mr. Ricky Afrianto, the area of triangle is 48.
Okay, thank you. So you have found something here. If you're thinking of, I'm assuming you're thinking of the second one, I think you might want to use that information that you have found in order to find the length of a side of a square ABCD. And then in a minute, I will show you what the solutions look like. Okay. Some people are also trying the drawing here. Okay, let me see in the chat. Okay, I'm gonna stop sharing for just one moment so I'll be able to see. Okay. Is there anybody that found an answer for 1 already? Let's see. Oh, Miss Indah Putri found this answer. So let me just show it. This is from you. Okay. Thank you for your answer. So the answer is the difference between the shaded areas is 4. Okay, thank you. That's okay. That's okay, Miss Indah. You have shared it with us anyways. What make question number, I guess let me make it a little bit more general so you will feel more convenient to share your response for this one. So let me just get out of this first. Okay, so teachers, what make, this is called novel questions, right? So something that is unfamiliar, something that is non-routine, certainly. That's what I picked because that's our aim for today's session anyways. So what makes this kind of question So both number 1 and 2, both are certainly a little bit more challenging than the routine ones, such as find the area of, and then you put that single shape. Okay, but what makes this one difficult? Maybe you would like to respond to that one. What part of this diagram make it difficult? Anyone?
We're still waiting for them to respond.
Okay. Maybe we can invite Miss Indah, since she was sharing a little bit earlier with us. Miss
Hello,
Indah, can we hear from you?
Yeah.
Hi.
Hello, Miss Indah. Good to hear your voice. Yes. Would you like to share your thoughts, because you were attempting at solving this problem earlier?
Okay, because the question is triangle A and triangle B overlap each other as shown, and the base of triangle B is 2 centimeters and its height is 4 centimeters. The base and height of triangle A is twice, that's the clue, that of triangle B. So find difference between the shade areas. So first, I'm looking for I'm finding out the area of triangle B. So the formula is 2 times 4 divided by 2. Yeah,
Okay.
and then I get, where is my answer? Yeah, so 2 times 4 divided by 2, I get 4. So the area of triangle B is 4. And then, because since the clue is triangle A is twice that of triangle B, then I double the area of triangle B. So double of 4 is 8. But I'm not sure about the difference between the shaded areas. So I just subtract 8 by 4 and I get 4.
Thank you, Ms. Indah, for sharing with us. So Ms. Indah uses the fact that she knows about finding areas of triangle, right? And then she calculated the area of each of the triangle, and then she's trying to find the difference between those two areas. There is a part that she identified that she was not sure about. She's not sure if that is the difference between the shaded areas. Okay, thank you for sharing with us. And of course, in your class, you probably would allow this sort of problem probably as something that, like what I said earlier, yes, you want to do it more and more regularly, as in it's more and more regularly becoming part of your lesson, but factor that into the planning time as well, because sometimes in order for students to think through this kind of problems, of course, we would anticipate a little bit more time, right? Okay, so let me show you the solution. Once you look at the solution, you might be surprised, okay? You might be a little surprised at the solutions. Okay, so let me just show it to you.
Triangle A and triangle B overlap each other as of triangle A is twice that of triangle B. What do we need to find? We need to find the difference between the shaded areas. How can we solve the problem? We can draw a model. From the model, we can see that the difference between the shaded areas is the difference between the area of triangle A and the area of triangle B.
Does it make sense to you? So this is the model for the area of triangle A, because the whole area of the triangle A consists of the white area over here, okay, which is this part, and then plus the remaining part of triangle A. In the same way, the area of triangle B consists of also a small part there, right? Plus the rest of the area of triangle B that is colored with yellow. Okay, so that's the whole area of triangle B consists of the parts that overlaps plus something more. And that's also the case with triangle A. So if you see here, If you're familiar, again, if you're familiar with bar model, you know that in this model, what do you notice about the size of the white part? What do you notice about the size of the white part? Because that's really the key, right? Once you're able to look at the model and you look at the size of the white part here, that should really help you with the next step. Notice that these are the same, right? So no matter what this amount, they're the same. So really, if you just want to find the difference between the shaded areas, these are the difference between the two, right? So let's look at the solutions.
First, we have the base and height of triangle B. We can find the area of triangle B.
And then the steps will just
Triangle
be...
A is 6.
So the steps that Miss Inna
Lastly, we can find the difference between the...
It's just subtracting, right? Subtracting these two.
areas of triangle A and triangle B. The difference between the shaded areas is 12 square centimeters.
And then notice also the way to check.
If the area of the overlapped region is 1 square centimeter, then the area of the red region is 15 square centimeters and the area of the yellow region is 3 square centimeters. The difference in area is 12 square centimeters. Triangle A and red region is 13 square centimeters.
Okay, so that's just for checking, right? So I guess what makes it difficult, and maybe some of you are thinking, this can also be solved, of course, algebraically, if some of you are thinking that way. But I guess what the model was really, I think that the key to understanding this problem is the overlapping part. It's just the same amount for both A and B, and then you work it out from there. So let me now show this one right here. This is also two shapes with overlapping areas. And I'll give you some hint. Oops, sorry. Let me give you some hint here. I've tried to create a model. So consistent with the previous one, I've tried to come up with this model right here. And let's see if you can make use of this model in order to figure out the solution to the novel question that we have over here. So here for the first model, I just created an area of ABCD. So the first model represents the area of the square ABCD. Okay, I created 4 parts here because I know that one part, a quarter of square ABCD is shaded. So that's one part of 4 equal parts, right? So that's, the color is yellow. This is the part that's shaded. So it means the remaining part equals to 3/4. So 3/4 of ABCD is not shaded, right? What else do we know? That's typically how you would guide your students, right, in solving any word problem. What else do we know about this problem? Okay, we also know something about the area of triangle EFG. What do you know about area of triangle EFG? Do we know the numerical values for that? Do we know the actual area? No, we don't. But how do we know, how do we connect the two areas? Again, the clue for you is here. The area of a square ABCD is 2/3 of the area of triangle EFG. And this is grade 6 level. So the assumption, if you're going through the curriculum, the Singapore curriculum, the students would have learned the basic of ratios already. Okay, so when it says 2/3 of the area of triangle EFG, maybe you can ask your students, okay, then students, what does it mean by 2/3? Or you can even start by asking which area is larger? Is that the triangles or is that the square? And of course, as you see from my model, the area of EFG, the model for the area of EFG is just a little bit longer, right? The ratio is 2/3. So if we know that there are 4 parts here for A, B, C, D, we know there should be more part for E, F, G. Okay, so think about that. 2/3 or 2 to 3 in this case is equal to 4 to what, right? So that's how you can scaffold it, because we know it's 2 to 3, but we have already obtained that A, B, C, D is represented with 4 equal parts. So what should be, or how many parts should area of EFG be represented by, right? How many squares? So area of EFG should be 6 squares. So here is 4 and here is 6. So the ratio of 2 to 3 is equivalent as 4 to 6. And because we know that in triangle EFG, that's also that shaded part, right? So it means that that's the same exact part being shaded as it was in square ABCD. So that's the reason for the same size and same coloring. So one part of EFG is also shaded, because look at the diagram, that's what it tells us. Okay. Now, what else do we know? We do know that the total area of the unshaded part is 72 square centimeter. So here, the unshaded parts are just the remaining parts. They're not yellow. So now you see how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. Now, I think I saw something on the chat. I do not know if that is the answer to this or if that is something else. Ocha, can you help me with that? If somebody is answering already?
Yes, Miss Riana Sari says 6 centimeters.
Oh, okay. Thank you, Miss Riana. Okay, so now from this model, so that's a little bit of hint now, right? So you know that the total area of unshaded part is 72 square centimeter. And you also know that the total area of unshaded part is represented by 8 equal parts. Does that ring any bell? Does that help you think through how to find the length of a side of square ABCD? Feel free to add to the answer. Thank you, Ms. Rihanna, for getting us started with the answer. Does anybody, would anyone like to guess what would the next step be? I have provided the answers here, but I'm not showing it to you right away because I'm hoping that you'll be able to figure that out. Feel free to type in the chat, or you can also speak to us directly if you think you know what the next step will be. Is there anybody who thinks that they can connect between the models and the information? I think there's something popping up in the chat, right?
Yeah, it's from Mr. Miftah Nur Farid. He says total area equals to 72. So 1 unit equals to 72 divided by 8.
Ah, wonderful. So you have made the connection. 8 equal parts equals to, thank you for your answer, by the way. 8 equal parts equals to 72. So I will be able to know that one part is equal to 72 divided by 8. Wonderful. How does that help us? What's going to be the next step? Let's try to complete the puzzle here. Who would like to pick up on the next step? So now we know that one part or one square represent 9 square centimeter, right? How does that help us? Reminder, the question is asking us to find the length of a side of square ABCD. So we still have a couple of steps possibly, right, in order to get there. By knowing that one part is equal to 9 square centimeter, what can we know about area of ABCD? Perhaps that can be the next question that you are using, right? If you were to guide your students in the same process. Anyone?
From Miss Maria Cristina, 8 parts equals to 76. And then she also typed 8 parts equals to 72. And then 8 divided by 4. Or is it the ratio? I don't know. It's some kind of like a ratio or divided by.
Okay, okay. So now here, does it make sense to you? Have a look for a bit. Sorry, I didn't mean to cut us short, but we do need to kind of have some limit also, right? So we've managed to find until here. And because I know that one part is equal to 9 square centimeter, I just ignore the units for a bit in here. So I know that the area of the square ABCD equals to 4 equal parts, right? So if one part is 9, I know that 4 equal parts shall give me 36, right? So area of square ABCD equals to 36 square centimeter, okay? And therefore, it can be used to find the length of the square, okay? When I did this activity with a different batch, a different group of teachers, one of the teachers says, you know, the way to help students remember about square numbers such as 36, she said, you know, multiplying twin numbers, so multiplying the number by itself twice, right? So that's kind of the case here. 36 is the products of 6 and 6. So that's how you can find the length of the square. And of course, in order to check it, you just input all the information back to what the question is giving you. Phew. And that's how you solve a novel question, right? So you may use a model. What about in a real classroom? Can students also use other method? Yeah, it's possible. I don't know if this is a more complicated method or actually a more accessible method for my students sometimes. Let me just show it to you for a bit. So what I did with this was I anticipated that whenever I gave that sort of problem, you know, the novel type of questions, some students would prefer, I'm just going to give it a try. You know, give it a try. What do you mean by giving it a try? Just insert a number. So that's kind of like the idea behind this possible solution as well. Sometimes students would put, there's a name for this. Another name for this is also guess and check. Some people call it trial and error. And here, this is also the use of technology. Of ABCD. All right, 2 square. So I'll get 4 square centimeter. If the area of ABCD is 4, what's the area of EFG? Remember, the ratio is 2 to 3. Okay, so the area must be 6. What's the total area of the unshaded part? Well, the unshaded part means you take away a quarter from 4. So that's going to be 3. And you take away a quarter of 6, which is 1. A quarter of 4, and that is 1. So you'll have 3 and 5, so you'll get an 8. And that's why I'm using a technology, because I'm putting formulas and stuff. And this is for grade 6, right? So in this process, I've tried to do a couple of examples here with different values of the length of a side of ABCD. And finally, once I get to 6, I am finding the desirable amount. So here, maybe there's a chance that sometimes, not just in this kind of questions, but in the questions where the quantities are not given, some students might just venture and think about, you know, I'm just going to insert a number there and see how it works. And because again, what we're trying to develop is just the creative thinking and problem solving skills, we might as well let them try and see where they go with it. Okay. So that's just another possibility. I do not know if any of your students at grade 6 level would already learn this much about algebra, but of course the next possible solutions is using or forming an appropriate algebraic equation such as what you see on the board. Okay. So using algebra, is that okay to use algebra? You know, like sometimes students take a look at us using models and they're wondering if other strategies such as algebra, which is generally more straightforward, is also acceptable. Of course it is, okay, as long as they know how to use it properly in order to solve the problem. So thank you, educators, for trying that out with us. Let me just save that discussion part later so we can pull the responses and also the questions towards the end. But I do want you to also try this out because this is the last activity idea I'm sharing with you, and it's called approve or disapprove. Okay, so this is aiming at, again, the evaluation level, just providing justification, providing a reason for your answer. So the activity I have here is just one question, and actually not one question, let me revise that. This is a statement. The shortest side of a rectangle with area of 24 square centimeter and perimeter of 20 centimeter is 3 centimeter. Okay. In order to collect your response, this time I would like you to access a Google Docs. And in the Google Docs, you can expect the same thing. So the statement is, suppose you have a rectangle. The picture here is supposed to help you visualize the information a little bit better. So this rectangle has an area of 24 square centimeter and the perimeter is 20 centimeter. Now the statement I give you, if those two are the condition for this rectangle, do you approve or disapprove that the shortest side of that rectangle must be 3 centimeter? Okay, so thank you, Ocha, for sharing the links with us. And let me access that document also so everybody can see my screen. So the link to the Google Docs, thank you for accessing it. I think the idea is that I've provided just as many rows here as possible. And you can also add more rows if need be. So you can record your answer. So first of all, the question is, do you approve or disapprove? So you can say approve if you agree, or if it's a yes, or you can disapprove if you disagree. Okay, and of course, we're interested to know why, right? Not just the answer, but why? Why do you approve? Why do you disapprove? Can you provide a valid mathematical reason behind your choice? That's something that you can also encourage your students to do in class if you are interested to try out this activity with them. Let me wait for a bit because I'd be interested to see what do you think of that. So the area is 24 square centimeter and the perimeter is 20. Is that true that the shortest side of this rectangle will be 3 centimeter? I would encourage you to fill it out in the Google Docs so everybody can see what everyone else is thinking. Please do not worry if your answer is different from someone else. This is a learning community for all of us, right? So we're learning together. Okay, somebody, Mr. Raymond Dale says disapprove. Okay, thank you for the answer, sir.
And Miss Rihanna is answering in the chat box, Miss Linda. She is also disapprove.
Okay, okay. Okay, disapprove, it should be a 4. Okay, thank you.
And also Mr. Ricky Afrianto here says disapprove also in the chat box.
Mm-hmm. Okay. Yeah, this one will require a little bit of time. So let's be patient as people are typing their answers. But so far, I think I start seeing the pattern here. 1, 2, 3, 4, 5, 7 answers that come in so far. Identify the statement as they disapprove the statement. Okay. So somebody give correction, right? Like the first answer disapprove, it should be a 4. Okay. Oh, okay. Somebody is giving a comparison between shortened length and longer length. I'm reading the one here. If the shortened length is 3, so the longer one must be 7. Okay, and of course, in your class, you can also ask follow-up question. Why is that? Okay. Oh, because you're using, I suppose you're using the perimeter for that one, isn't it? If the perimeter is 20, then the longer one must be a 7, because you know that the perimeter of a rectangle is just twice the sum of the longer side and the shorter side, something like that, right? And if that is the case, then the area would be 3 times 7. So that's going to be 21 square centimeters. So it's no longer consistent with both conditions that are presented here. Okay. Okay. Somebody is thinking, okay, hang on a second, it should be 6 and 4 instead. So let's take a look at that. It is correct. 6 times 4 equals 24. And that is the correct area of the rectangle. And now let's check whether the perimeter is also correct. 6 and 4 together make 10, right? 10 times 2 is 20. Wow, okay, well done. So it should be a 4, and that confirms what Mr. Raymondale is saying here, that the shortest side should be a 4. So you see that this is in grade 4, students are already introduced to a rectangle and a square. And actually by making, probably students are so used to find the area, find the perimeter of a rectangle, and they probably have obtained some content mastery in that area. And when they have done so, then they are ready for this kind of challenge, right? Because they're familiar already with area and perimeter. But now what this question is intending is just, now that you have this area and perimeter, in the same question, could you find the correct dimension? Could you find the correct measures of the sides?
Okay, Miss Linda, maybe we can continue to the slide because we only have about 5 to 10 minutes more.
Sure.
Okay. Thank you.
Having too much fun with that one.
Yeah.
Thank you for the reminder. Yes, I am intending to come back to it. So, yeah, educators, I would like to, we're getting close to the end of the presentation. Okay. And I guess I would like to leave this with you. Sorry, let me try that again. And then we're going to go to the last activity that will make use of the flip grid. Okay, so sometimes another trick or another possible ideas for you to develop higher order thinking skills is also by, approving or disapproving means some statements are going to be false statements, some statements are going to be a true statements. Okay, and sometimes the way we treat mistakes, let me actually show you this really quickly. We're not going to do this activity now because of the time constraints, but let me just show you so that statement will make more sense. So here's another idea. You can also ask your students basically to analyze mistakes that they themselves or someone else is making. So here are 3 samples. So suppose you have a question. Here are 3 sample answers, and then analyze which one is the correct or find which one is the correct answer. Or even better, if you provide 2 answers that are incorrect, ask them to actually talk about it. What makes this answer incorrect? This has have been proven effective across different topics. For me personally, when I teach algebra, typically I'm using this kind of approach to just make my students think a little bit more deeply about what they do or what someone else's do and why certain things are acceptable, certain things are not. So sometimes mistakes does allow thinking to happen. We do that all the time, don't we? When we are talking with our colleagues about the mistakes that students are making in our math classes, we're actually getting involved in the process of evaluating not just the students' answers, but also our own practices, right? So let me just leave you with this thought very quickly before jumping into the last activity. So mistakes are, in a math class, I would encourage this, that mistakes are expected, respected, inspected, and corrected. Sometimes as a math teacher, I'm also guilty of this. I'm jumping straight into correcting the mistakes, right? Well, hang on a second. Sometimes those mistakes can actually be a really good point of discussions. It can allow some really good thinking to happen, can allow your students to think more deeply. So I would encourage you to make use of those moments or those appropriate examples of mistakes cautiously in order to promote deeper thinking or deeper learning. Okay, so the last one here, you might be wondering why you were asked to download a Flipgrid, and let me just show you. So I basically have a question here, and the question is about finding percentages. And the activity that I was hoping to do a little bit with you, or at least showing you at the moment, is to justify a method. So I provided 3 different methods here. Here's the first one. So basically the problem is just asking what percentage of the flats in the block are 4-room flats. I provided 3 possible methods. Do not worry, I'm gonna go through this quite fast, but I will show you the link to the Flipgrid so you'll be able to replay the video again at your own time even. Here's the first method shown by Ali. Here's another one shown by Beth. And here's the last one shown by Karen. So I think we're ready for the link for Flipgrid, Ocha. So at least the educators can take a look at the examples that I've had there.
Yeah, the link is already in the chat box, yeah, educators?
All right, thank you so much. So I'm just going to show you, once you have managed to get into Flipgrid, just a brief overview of what Flipgrid is, and then I'm going to play one of the instruction videos that I've posted there, okay? So once you're able to click on the link, and plus you have downloaded the application, Flipgrid is like a video discussion platform. So suppose you are giving a question for your students to solve, or in this case, I'm showing 3 different methods to solve the same questions. And I would like a verbal response. So I would like my students, or in this case, I would like the participants, you teachers, to give me a verbal response. So other than a written answer, I would like you to record yourself. Flipgrid is an excellent platform to do that. Okay, you can either record yourself if you're familiar with Instagram and like Instagram story, you know, you're making short videos that show what you are doing at a particular time. This is kind of like that. Let me just show you what I have made here. I did say that you would be able to come back to my instruction. So let me just play this very briefly. It's played already.
Okay, so in this case, I would like you to justify a method. And there are 3 methods that I have shown you. This is the first one. A student named Ali uses a multiplication by 100%. And these are the steps that lead to the solution.
So you can also use that feature. It's kind of like there's also another screen capture type of platform wherein you can capture your screen and then record your voice. There's another example there. I have asked a colleague to kindly record herself while she was doing the activity. But I guess after this session, if you're interested, you can try to record yourself. Do not worry, because unless I am approving your video, no one else will be able to have access to the video but you, okay? So if you're a little concerned about privacy, do not worry, it's not going to go public, okay, you know? So that's just the tool, and the intention of that question or that exercise is, of course, when there are multiple methods to solve the same question, could you pick a method that works best for you? And another side of that is also, could you justify that method? Why is that method mathematically correct? Okay. All right, let me stop there because I would like to also address some of the questions before in the previous session, right, Ocha? There were a few questions that I didn't yet get the chance. Maybe if we can select 2 questions related to our topic today, and I would like to spend some time answering them.
Okay, so there was a question from Miss Yunita Rahmawati. She asked, these kind of activities are so fun to enhance the students' critical thinking, but sometimes the students are just confused to solve it. Besides, the school is also have so many goals to gain. How to maintain that, Miss Linda?
Wow, it's a question that many of us, I think, can relate to. And there's multiple challenges in there, right? Like first one is how do I balance between doing this sort of activity, but also still meeting the goal of what my school has intended for every student to achieve. Okay, I don't think there's an easy answer to that, and I do think that once you have, every time you have gained new ideas and you are ready to implement it, I would really highly suggest that you come back to your team of teachers. So let's say if you're all teaching grade 3 or grade 4, and then you think about how to best plan this kind of activity carefully into your weekly lesson plans or into your units. Okay, so if you are a kind of person who would like to have planned this better so that you can meet the other learning objectives while also have rooms for this sort of activity, then come back and plan it together, okay, with your team. Typically, I would say, probably it's different for every cases, but at least if you can insert something like this, you know, the sort of activity at least once or twice in your units, I think it's better than nothing, right? To get started, maybe once or twice in your units, and then you can increase the frequency of doing that activity more and more as you are also gaining more confidence in knowing what the time frame looks like, you know, knowing which one is more suitable, where is it more suitable to do, and stuff like that. So bottom line is collaborate, work, discuss with your teams in order to decide about the timing. Okay, but I'm glad you found the activities useful, and I'm sure you are eager to also apply this in your class. Maybe one more, Ms. Ocha?
Yes, there was a question from Miss Derty Elizabeth. So when we make questions, especially HOTS questions, we need to create questions with many possible answers, Miss Linda. So maybe you can also remind us again about the characteristic maybe of the HOTS questions, Miss Linda?
Sure. And let me just go back to that because that's at the beginning of our presentation. I think that's a really good way to end or conclude our session, because that's one of the big takeaways that I hope you will obtain from the session. So thank you, Ocha, for the prompt. So here are the characteristics. Let me just show you from here. At the beginning, and don't worry, all of these characteristics will be in your handout as well. So that will serve as a reminder if you wish to incorporate this into your lessons. So the characteristics of tasks that promote HOTS: the steps are not directly predictable and cannot be determined completely. It's not a routine. There are many solutions, or I guess this is the part where I will stop and add a little bit. I did say that there are many solutions, or even when there's only one solution, there tends to be multiple ways to approach the problem. So when there's only one way and one way alone to solve a particular problem, so for instance, like in our warm-up activities, if that was in the typical routine problems and you're giving students 2 or 3 numbers to add and come up with an answer, there's only one way to do that, right? I mean, yes, you can probably think about, yes, you can use manipulatives, you can use picture, but basically the method is add those 3 numbers and that's it. All right. But once you tweak it a little bit, it becomes many alternatives, right? And of course, probably some of you are wondering, then how can we begin? I would suggest you can make use of some of the ideas that I have shared here. And when I shared ideas, it could be the activities right away you directly apply as is, like the one that, for instance, broken calculator, or which one doesn't belong. Or as a teacher, when you look at that activity, look at what characteristics of HOTS is present there, or what makes that problem unique or different than the routine one. Then I believe you can craft something that is directly applicable to your class situation at that time. Okay, so that's my goal. It's not something that I should prescribe for you. Here's the formula and you should do it. It's just different, right? When we're talking about teaching certain mathematical topics such as fraction or whole numbers, that's what I can promote to you. I can give you, here are the steps, but in this case, I kind of open up the ideas, or sharing the ideas to inspire you, so that you can come back to your class and craft those problems with this kind of characteristics. Okay, I think that's going to be my answer.
Yeah, okay, thank you very much, Ms. Linda. And maybe that would be the last question on in this session. Maybe do you have any closing statement, Ms. Linda, for us?
Sure. Yes, I do. Okay. So let me close out by sharing the statement with you. So let me go back to my presentation. I do want to share this quote from a very famous person, from Albert Einstein. He says that education is not the learning of the facts, but the training of the mind to think, by Albert Einstein. And the ones in the bottom is my addition to it, because I know as a teacher reading this fact, I would think, well, isn't it necessary to know the facts though? They're foundational. So I'm adding an extra note here, and I'd say knowing the facts is necessary, but it should not be the end goal of the education. Especially in math, we would like our students to be effective problem solvers by learning mathematics. So thank you so much, educators. I'm having a blast with all of you with your questions and participations, and I hope this session has been fruitful and beneficial for you. Over to you again, Ocha.
Okay, that's great. Thank you. Thank you very much, Miss Linda. And hopefully by these sessions, the participants are enlightened and also have our mind refreshed, especially for HOTS, high order thinking skills for maths primary. Thank you very much, Miss Linda. And also participants, don't worry if you still have any question. You can also deliver your question to the written email and WhatsApp number on the screen.